Welcome to doassignment-ca. Here is the problem. Car B is traveling a distance d ahead of car A. Both cars are traveling at 60 feet per second when the driver of car B suddenly applies the brakes, causing car B to decelerate at 12 feet per second squared. It takes the driver of car A 0.75 seconds to react, which is a normal driver reaction time. When car A's driver applies the brakes, car A decelerates at 15 feet per second squared. Determine the minimum distance d between the cars so as to avoid a collision. Now let us work through the solution step by step. Let's set up the problem. Both cars start at 60 feet per second. Car B immediately begins braking at 12 feet per second squared. Car A's driver takes 0.75 seconds to react, then brakes at 15 feet per second squared. We need the minimum gap d such that the cars just barely avoid colliding. First, let's figure out when each car stops. Car B, decelerating at 12 feet per second squared from 60 feet per second, stops at t equals 5 seconds. Car A starts braking 0.75 seconds later, decelerating at 15 feet per second squared, and stops at t equals 4.75 seconds. So car A actually stops before car B does. The critical moment is when the gap between the cars is smallest. That happens when both cars have the same velocity, or in this case when car A stops at 4.75 seconds. At that moment, car B is still moving forward at 3 feet per second, so the gap is at its minimum right when car A stops. Now let's compute how far car B has traveled from its starting point by t equals 4.75 seconds. Using the kinematic equation, car B travels 285 minus 135.375, which equals 149.625 feet. Car A travels in two phases. During the 0.75 second reaction time, it covers 45 feet at constant speed. Then it brakes for 4 seconds, covering 240 minus 120, which is 120 feet. The total distance for car A is 165 feet. Car B starts d feet ahead. At 4.75 seconds, the gap between them is d plus 149.625 minus 165. Setting this equal to 0 for the minimum distance gives d equals 165 minus 149.625, which is 15.375 feet. Rounding, the minimum separation is approximately 15.4 feet. Let's verify. With d equal to 15.375 feet, car B's position ahead equals exactly car A's position at the critical instant. The gap is 0, confirming this is the minimum. After this moment, car B moves forward and the gap grows. The answer is confirmed. The minimum distance d is approximately 15.4 feet. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.